Hi, this is Paul Will of Cleveland Cliffs, a member of AIST. Today's Monday, April 12, 2021. We're doing an interview via AIME's Zoom conferencing with Dr. Alex McLean, Professor Emeritus at the University of Toronto. Dr. McLean is also a distinguished ISS and AIME member. This interview is being conducted as a part of AIME's Oral History Project. Dr. McLean, welcome and thank you for spending some time with us today.
Most welcome, Paul. Most welcome.
Well, let's start with the early years. Tell me about where you grew up.
Well, Paul, I was born, as you probably well know, in Scotland, in a very small town, a little bit bigger than a village, called Blantyre, about 9 miles south of Glasgow. Blantyre was the place where the missionary David Livingstone was born. And just a small town, but as I say, about 9 miles from Glasgow, about 3 miles from another place called Hamilton. Hamilton in Scotland. There's a lot of Hamiltons around, but that was Hamilton in Scotland. And I lived there until we got married. Betty, my wife, and I met. Betty was also from Blantyre, and we met together attending the same church there. And after we were married, we moved to a small town called Largs, L-A-R-G-S, on the west coast of Scotland. And we lived there for a couple of years before we moved to Canada.
That's very nice. So what did you do? What did your parents do for a living?
My mother, she was a homemaker. She looked after things at home, did a great job there. And my dad, he left school when he was 14. That was what they did in those days, most people. He left school when he was 14 and joined the local Foundry, metalworking plant, located also in Blantyre. So I remember as a boy growing up, if my father was working overtime at the Foundry, I would take him his sandwiches for his meal in the evening. He would take his lunch with him, but if he was working late, I would take an evening meal too and meet him in the Foundry and sit there with him. And it was great to sit beside the foundryman because, of course, in the Foundry, at least in those days, they never had fridges. So they always would take their tea black. In other words, their tea was taken without milk. And up until that point, I had always taken tea with milk. But when I would take my father's sandwiches to him for his evening meal and sit there beside him and the other men, oh, I just felt so grown up because they would give me this tin mug, because you never used glass cups. It was a tin mug with black tea. And ever since then, I have always taken my tea black, although I take milk in my coffee. But all of that to say, right in the very early days, I used to visit a foundry. And of course, there's very distinctive smells associated with a foundry because there's small furnaces there. They're doing sand casting and then they're processing the metal, cutting and filing and shaping and so on. So I had a kind of foundry beginning in that sense.
So would you say that your father had a tremendous influence on the fact that you become an engineer later on in your life?
I would say that's absolutely right, Paul, based on what I've just mentioned to you. But I can remember one day while I was still in high school and getting ready to prepare, to go to university, my dad coming home from work and I was sitting at our table together where we were having our evening meal there about 5 o'clock in the evening, we generally had it. And he said to me, so what are you going to do when you leave school? And I said to him, well, I think I'd like to be a painter. And he said, do you mean an artist? Oh, no, I said, just a painter, somebody that paints walls. And, why would you do that? He said. I said, well, I like the smell of paint. This was before the days of drugs and things like that, and maybe I was a druggist at heart, I don't know. But I like the smell of paint. And I said, the other thing is, you start at one end of a wall and you get to the other and you can look back and you see what you've done. So I think I might like to be a painter. He said, well, you really don't need to go to university if you're going to be a painter. He said, what do you like doing at school? And I said, well, I like maths and chemistry and physics. And he said, maybe you should be a metallurgist. Over here, we say metallurgist. Over in Scotland, we said metallurgist. And I didn't know what that was. I said, what's a metallurgist? He said, well, I'll arrange for you to visit the local steel plant, and you'll see them making steel there. And they always need metallurgists. And if you study metallurgy, you would always have a job here in Scotland, because we had a number of steel plants locally, being very close to Glasgow, as I'd mentioned. There were a number of steel plants locally. So that was a major source of employment. So sure enough, I visited a local steel plant and I saw them. At that time, we didn't have BOFs or converters, Paul. There were still open hearths and electric furnaces. And I watched them tapping open hearth furnaces into ladles and pouring ingots, because we didn't have continuous casting either. But boy, the smoke and the flames and the heat and the dust, I thought, this is marvelous. To be able to do chemistry at, it turned out 1600 degrees centigrade, that would be a great thing to do. So that got me hooked on it. And from there on, I decided, oh, I'll study metallurgy, which I did. So that was how I got started. So very much as you have suggested, that my dad had a big influence in my decision-making there.
So it sounds like you like everything pyro related. You like high temperatures and fire.
That's right, yeah. A pyromaniac, I think.
It's a great segue into your education background. So in addition to receiving an applied chemistry degree from the University of Glasgow, you also received an associateship from the Royal College of Science and Technology, now the University of Strathclyde. And why did you choose that school?
Well, that's a good question, Paul. It turned out at that time, as you say, it's now the University of Strathclyde, but at that time when I was about to enter it, it was called the Royal College of Science and Technology. And it had an interesting linkage to the University of Glasgow. It turned out that the professor who was chair of the metallurgy department, as they called it, the metallurgy department at the University of Glasgow, the department and the chair was actually located at the Royal College. So it was the Royal College that I would be attending rather than the University of Glasgow, as it turned out. But even beyond that, at that particular time, that was the only department of metallurgy in the whole of Scotland. There were several departments in England, but there was only one in Scotland. So to study metallurgy, it was the Royal College of Science and Technology that I would attend, which I did, and thoroughly enjoyed my time there.
Well, that's great. And while pursuing that, the degrees that you received over at the University of Glasgow, did you take any internship? Taking on any internship while you're there?
Yeah, between the sessions over there were a little bit different from what we have here in typically in North America. The session would begin in October, and it would run through till June. So the months July, August, and September, you were off. So between my first and second year, and second and third year, and third and fourth year, and then immediately after my fourth year, I spent 3 months each of these times working at a company called David Colville and Sons. That was the major steel company in Scotland, and they owned a number of steel plants. And the one that I worked in was the one that I'd actually visited, that my dad had arranged me to visit while I was still in high school, and it was called DL Steelworks, and it was located in Motherwell, which was about 4 miles from Blantyre, Burnbank, 2 villages close to each other, where I grew up. So it was very easy to get to DL. So DL Steelworks had a great history. It was the place where the steel for the Titanic was actually made. Now, as you probably know, Paul, the Titanic was built in Belfast in Ireland, but the steel came from Dalzell Steelworks. And the Queen Mary, which is now located at Long Beach. If you ever visit Long Beach, you can visit the Queen Mary. The steel for that vessel, which was built in 1936, and at the time was the biggest ship built in the world, that steel also came from Dalzell Steelworks. And if you ever visit the Queen Mary at Long Beach and you go down to the engine room and you look up in the big steel beams, you'll see them printed in these beams, Dalzell Steelworks Motherwell. So that's where I spent my internships, and again, thoroughly enjoyed that experience, working in an open hearth shop and watching and observing and participating in the casting of ingots and the rolling of slabs.
Wow, what a fascinating connection. So for the, I was just curious, for the Titanic, when was it built?
Normally trials at sea for a new ship might take a couple of weeks, but for the Titanic, it was one morning outside Belfast. That was it, and then it was on its way. In fact, they were in such a rush to sail and get across the Atlantic, it turned out that the crew that they used for looking ahead to see if there's any problems, they would have a couple of members of the crew up in the mast right at the front of the ship called the Crow's Nest with binoculars normally, watching for any ships or icebergs. And it turned out they were in such a rush to sail, they sailed without any binoculars. And if these guys up there in that Crow's Nest had been equipped with binoculars, they would probably have spotted the iceberg a little bit sooner than they did. And that alone might have saved the Titanic. You know, it's often reported, and it's true, that the Titanic had steel with a high sulfur content, with 650 ppm. But that was typical sulfur for steel at that time. It's just the ship was not built to be an icebreaker. It was meant to sail the ocean. And that steel was sufficient for that purpose, but it sure was not appropriate when it hit an iceberg where the temperature of the seawater was probably about 0. And at that temperature and 0.065% sulfur in the steel, subsequent tests, in fact, I have a piece of that Titanic steel that was brought up from the Atlantic Ocean, received it from the mines branch in Ottawa. That steel, when you do a Sharpie test on it, at that temperature, 0 degrees C, it had the ductility of glass. In other words, no ductility at all, brittle as glass. So it was a very unfortunate combination of circumstances that led to the disaster of the Titanic.
Fascinating story, fascinating connections. And later, of course, you completed your PhD in metallurgy at Glasgow as well. And what convinced you to pursue an advanced degree? And why chemical metallurgy?
Well, that's a couple of interesting questions, Paul, because as it turned out in those days, it's very different from today because it's some time ago. In those days, the head of the department, who happened to be a very fine gentleman called Professor Hay, Professor Robert Hay, he was close to retirement when I joined the department and finished my bachelor's degree. But he approached myself and one other student in the class, a chap, a good friend of mine by the name of Archie Vetters. And he stopped Archie Vetters and myself in the hall just after we had completed all our exams for our bachelor's degree. And he said, how would you two fellows like to do PhDs? Because we didn't do masters at that time. You went straight to a PhD. So we kind of both looked at each other and thought, yeah, that might be a good thing to do. And then Professor Hay, he said to Archie and myself, he said, Vetters, that was Archie's second name, Vetters, you're better than McLean at maths, so you'll do physical metallurgy. And he said, McLean, you're better than Vetters at chemistry, so you'll do chemical metallurgy. So each of us ended up doing that. But the interesting thing was Professor Hay had got it back to front. I was actually better than Archie at maths, and he was better than me at chemistry. But we didn't dare contradict him. So he ended up doing physical metallurgy, did very well, worked in Scotland for a while, and then ended up as director of the Welding Research Institute in Australia. And of course, as you know, my path was then in the field, through the field of chemical metallurgy. So that's how I got started on it.
That's great. After receiving your doctorate, you relocated to Canada within a relatively short time. What event prompted that move?
Well, I was still at Glasgow, of course, at that time. I was actually an assistant lecturer. They had appointed me as an assistant lecturer, so I was getting some experience of what it was like in academia. And Professor Bell, that I had worked with there at Glasgow, he received a letter from a gentleman called Professor Robert Ward, who came originally from Sheffield, a steel centre in England, and had moved to McMaster University in Hamilton, Ontario, not Scotland, Hamilton, Ontario. And he was in charge of steel research at McMaster. And Professor Ward had received funding from one of the local steel companies there, the two local companies. One was Stelco, the other was Dofasco. And Dofasco had provided money to bring in a postdoctoral fellow to work on inclusions and deoxidation. So he wrote a letter, Professor Ward did wrote a letter to Professor Bell saying, do you have anybody there that's just finished their doctorate who might be interested in coming to Canada for a couple of years and working in association with Dofasco on deoxidation and inclusions? So Bell suggested to me that it would be a good thing to do for a couple of years, good experience. So I discussed it with my wife. We had been married at that time for a couple of years, and thought, well, this might be an interesting activity to move over to Canada. It's a 2-year appointment. So we decided we'd make a move, said goodbye to our parents and sailed over from Glasgow to Montreal and took the train to Hamilton to work at McMaster for a couple of years with Bob Ward.
And it turns out it wasn't just 2 years, was it?
No, that's right. As the 2 years came to an end, because that was the length of time that you were allowed to hold a postdoctoral fellowship, I'd had a good 2 years there. Really appreciated and enjoyed very much working with Ward's group there and visiting Dofasco and various other companies. But at the end of 2 years, I remember visiting again Dofasco with Bob Ward, and meeting with the vice president there, a very fine gentleman called John McMulkin. He was responsible for bringing the converter steelmaking process known as the BOF. At that time, it was called the LD, Lintz-Donowitz process. He was responsible for bringing that process from Austria into North America. And Dofasco was the first company in North America to install an LD. So it was nice to work with McMulkin. However, all of that to say, Bob Ward and myself visited Dofasco, and Ward told McMulkin, well, the postdoctoral fellowship is coming to an end and McLean will be heading back to Scotland. And McMulkin said, is it not possible for him to stay here a bit longer? And I was just sitting listening to all of this. I wasn't involved in the conversation. I'm just listening to Ward and McMulkin talking away there. And Ward says to McMulkin, well, he could stay on, but he can't stay on as a postdoc anymore. He would need to be promoted to what we call a research associate. So McMulkin, who liked to kind of poke fun at me as a Scotsman, he had a kind of Irish background, I think, if we're going back in his heritage. But he used to tell me his wife had a Scottish background, and this caused him a lot of problems, he said. So he said to Ward, that probably means we'd need to pay McLean more money. And Ward said, oh, yes, you'd need to pay him more money if he moves from a postdoctoral fellow to a research associate. And McMulkin says, well, how much would we need to pay him? And at that time, I was getting $5,000 a year as a postdoctoral fellow, which was good money. And Ward, to my astonishment, Ward says to McMulkin, oh, we'd need to increase it to 10,000, doubling what I was getting. And McMulkin Oh, that's a lot of money, he said. And he was complaining about what it would cost. You know, Dofasco's a major company. At one point, it was the most profitable steel company in the world. But he agreed. So I then carried on as a research associate. It was the only time in my career I ever doubled my salary in one go. And I stayed on as a research associate. So that was what happened.
Well, Professor Ward is what I would call a wonderful mentor who is also capable of doubling his associate's salary. That is a great story. And I gather that Bob Ward eventually moved on to Australia. What can you tell us about that? What happened to your career afterwards?
Yeah, that's right. Bob received an invitation from BHP in Australia, inviting him to join the company, the steel company, the major steel company in Australia, to join them as their director of research. And they had major research facilities in a couple of locations, but they wanted to start a new one in Melbourne. And that was going to be a physical metallurgy lab. And they wanted Ward to head that up. So he was going to be based in Melbourne. And I remember him saying to me, this is going to be a physical metallurgy lab, but I would like to continue doing some work in that location on chemical metallurgy. Why don't you come with me to Australia and you can look after the chemistry laboratory inside that major physical facility? Oh, I thought about it. And oh, no, Bob. It's a long way to Australia. And to get back from Australia to visit Scotland, oh, that's an awful lot more difficult than traveling from Toronto to Glasgow, because you can do Toronto to Glasgow in just under 6 hours. It's a lot longer from Australia. I said, no, I don't think I want to do that. So he left and went to Australia, and we kept in touch right through many, many years until he passed away a few years ago. He was a very good friend. He gave me a lot of good instruction, advice, and mentoring. But I stayed on at Mac, and it turned out when he left, that created a faculty position. Now, I didn't move into the full professorship that he held, but I did join McMaster as an assistant professor and continued in that role for a couple of years. And then I got tenure, and they promoted me to associate professor.
Yeah, it's an astonishing achievement that you received your tenure within just 2 years. And shortly after, to the surprise of many, you went on to join the steelmaker. Where did you go, and what motivated you in making that decision?
Well, it was an interesting kind of scenario, Paul, because I thoroughly enjoyed my time at McMaster. I was there, I thought I was going for 2 years. In fact, I ended up being there 5 years. And as I say, I really enjoyed the work I had there. Worked together with a couple of other professors. We formed a small group and really enjoyed working together. But it was a situation where my university research had really become really too consuming at the expense of family life. And in that sense, I realized this is not good. And when I received a phone call from a steel company in Pittsburgh called Jones and Loveland, they were looking for somebody to head up a deoxidation and casting group and asked me if I would be interested in moving. And when I put the two together, I thought, boy, maybe I need a change from academia. And I certainly would appreciate working full-time in industry, because I had been doing some consulting work for industry while I was in the faculty at Mac. But there's a big difference from being a consultant and, as you would well know, from working full-time in industry. And I thought, here's an opportunity to move to a steel company that I regarded very highly, because I'd heard the presentations at conferences, and their papers were generally co-authored by people from research and also people from production. And that intrigued me, that the production people and the research people were working together and publishing co-authored papers. I thought, boy, I like that. So when I got a call from that company asking me, would I be interested in joining them? I thought, this is the opportunity to make a change. And I did. I moved to Pittsburgh and joined J&L.
Yeah, I have heard great stories about J&L. And as the supervisor, you joined the steel deoxidation and casting research group. As the supervisor of that group, what were your job duties like?
Well, it was a great experience, I have to say, Paul, because in that capacity, working at what was then called, no longer exists, I'm afraid, but was then called Graham Research Laboratory in Pittsburgh. I was involved in conducting laboratory experiments and having a team of people conducting laboratory experiments. And also they had an excellent pilot plant, which I was responsible for. And that allowed us to scale things up and work with larger size furnaces before going on to do actual tests on production facilities. So it really was a marvelous opportunity to follow something through from laboratory scale experiments through pilot plant trials, and then, as I say, testing on production facilities. And at that time, J&L had steel plants located in Pittsburgh, in Detroit, and also Cleveland. So I had the opportunity to visit these different plants, taking part in different trials and so on. And it was just a great experience, one that I never, ever regretted. Never did. It was so good for me.
And were there any particular challenges you recall from transitioning to industry from academia?
I think the biggest challenge for me, because while I was in academia, sure, I reported to the chair of the department, but that's a pretty kind of relaxed linkage. Whereas when you're in industry, there's a pretty tight chain of command, that goes through the system. And while in academia, you may be working with your own research group and students working with you, again, as you know personally. Once you're into conducting plant trials, and again, you'd be very much aware of this yourself, Paul, you have to rely on receiving a lot of help from shop floor operators. And that to me was very much a different kind of relationship from working within academia. It was a great challenge, and I thoroughly enjoyed it, I must say, and made some very good friends. Because in conducting these plant trials, you don't do it by yourself or even with your own team from research. It involves the people in the shop floor, and you're very much relying on them for their support and their input and for their advice and their observations that they have collected over many years. So again, a great learning experience for me, and I never forgot it.
Absolutely. Collaboration is key in the industry. And while you're at J&L, did you have any particular influences or mentors that you found was very, very helpful and you learned a great deal from?
Well, when I look back, Paul, names that kind of stand out, and there were a good number of them, names that stand out. First, the gentleman that recruited me, his name was Bill Dennis, another Englishman. I seem to always end up working for Englishmen, strange thing. But Bill Dennis had taken his doctorate at Imperial College in London, England, working with Richardson, working in chromium carbon relationships in stainless steel. And he was the one that had hired me. And he gave me a lot of good advice. I can remember when I first had an interview with him, and I was trying to determine, is this where I should go? Should I leave university and join J&L? And he said an interesting thing to me, which I never forgot. He said, look at it this way, McLean. He said, if you join us, even if you only stay with us for 2 or 3 years, he said, if you go back to academia after being at J&L for 2 or 3 years, do you think you would be a better professor or a worse professor? And of course, the answer was obvious. I said, I'd be better, having spent time in industry, I'm sure. And he said, supposing it turned out that you join us and you prefer industry to academia, it would be a good thing you made the move. I thought, boy, that's right. He said, so you can't lose. And I never forgot that. He said, you can't lose by joining us. So he was a great friend, and he kept in touch with me after I left J&L and went back to academia, and was responsible for a number of activities that happened later on while I was in academia at U of T. Another person that I reported directly to, who was in charge of the various groups there at J&L, was a gentleman by the name of Egil Åkrest, and he came from Norway originally, and he had a great background in steel research, and I learned a lot from him too. Then another gentleman that I still keep contact with, he worked as a member of my group, but he really was senior to me. So his name was Leon Loix, and he came from Belgium originally. And boy, did he know stuff about inclusions. He had studied back in Belgium mineralogy and geology. So he was a great microscope man. And boy, when we would go into the plants, he had been there, of course, many years before me. And although I was his boss, he knew an awful lot more about what was going on than I did. And he was a great teacher to me. And I never forgot Liam. I owed him a great deal because he sure helped me when we would go into plants to conduct trials and so on. And he really gave me a lot new understanding of the factors that influenced the formation of inclusions, not only deoxidation, but reoxidation and interactions with slag and refractories and that kind of thing. So these were folks that, when I look back, had a big influence on the kind of research that I then subsequently got involved in when I returned to academia.
And return to academia you did. And as if you have mentioned, after working for J&L, you did return to academia, and this time to the University of Toronto. And for more than half a century, you stayed at the University of Toronto. Why did you choose Toronto?
Well, I looked at different schools that had interests, obviously, in steelmaking. And the thing that caught my attention about Toronto, they had a very good guy there by the name of Professor Harry Ross, who was looking after iron making and steel making. But his particular strength was really blast furnaces, iron making, iron ore, direct reduction processes as well. He did a little bit of steel making, but his background was really iron making. And I thought maybe they might be interested in somebody with a background more in steel making. And just about that time, a gentleman, another Englishman again, by the name of Benjamin Alcock, again from Imperial College in London, England. He moved from Imperial College to Toronto. That would be in 1969, he moved from Imperial. And at that time, he would be in his early 40s. And it struck me, if he is, and he was a senior professor at Imperial, if he is moving with his family from England to Canada, to Toronto specifically, that's going to have a big impact on Toronto. So I contacted him to see whether there was any possibility of a position at Toronto in the area of steelmaking. And things were very different from they are today, I have to say, Paul. I had an interview with him on a Saturday morning. I met him in his office at Toronto on a Saturday morning, just him and I, and we talked together. And at the end of it, he said, well, you would be a good partner for Harry Ross, because Harry Ross is an iron maker. You would come in as a steel maker. And I would like to strengthen the area of iron and steel at Toronto. And that was it. I got the job. Today, you'd have to have a search committee established. You would advertise the position. You'd go through all kind of things. It would take weeks and maybe 2 or 3 months before an appointment was made. In my case, it was all over. It was all over in the morning. Maybe today I wouldn't have been able to get that job, but I did then. And boy, Ben Alcock turned out to be a great mentor and a great friend also. He was the one that said to me after I'd only been there, I guess maybe 2 or 3 years, if you really want to accomplish significant things in your research group, make sure you have a good second IC. And in my ignorance, I said to him, what do you mean by a second IC? And he said, McLean, a second in command. You need to have a good second in command, somebody that knows all that's going on, so that you're not trying to do it all by yourself. Because if you try to do it yourself, you'll limit how much you can accomplish. And I never forgot that. And over the years, I ended up with at one point three at the same time, 3 second in commands, all people that had their doctorates, some of them experienced in industry. And boy, that really strengthened the group. And it allowed us to do things to broaden our areas of activity that we could never have done if I'd been doing it just by myself.
And it's a great research group we had. And this research group called Ferris Research Group, we have built this up over the years, and it was recognized and funded by industrial partners. What was a major milestone that helped establish the group back in the day?
Well, there's no doubt in my mind the trigger that really kind of set us off on a good track. And that was when the American Iron and Steel Institute, AISI, they decided in their wisdom that, that they would award or create a new type of award called AISI Distinguished Professorship. And they created 2 of them at the same time. And one was awarded to the late John Elliott at MIT, and I received the other one at Toronto. And this AISI Distinguished Professorship carried with it research funds of $100,000 a year for 5 years. So having that foundational funding, $100,000 a year, which was a lot of money at that time, for 5 years, really gave us a great foundation to build on for subsequent support from other steel companies, because of course, many steel companies were members of the American Iron and Steel Institute. And so presenting papers at AISI meetings and meeting other folks at different steel companies, that it was like a rocket taking off for the moon. That really gave us a great boost. It was a great boost to have that professorship for 5 years. I remember when I did get it, the so-called distinguished professor, one of the students, certain things stay in your mind. One of the students said to me, which I thought was marvelous, he said, "Remember, after distinction comes extinction." It was a very humbling experience. Fortunately, extinction hasn't happened yet, so I'm still here. But that was his advice. Remember, after distinction comes extinction.
That is a great phrase there. What is your research philosophy running that group?
Well, I think at this particular age that we're in, there's a great deal of time that researchers spend on computer modeling. And I think it's important that we don't forget the importance of measurements, because these measurements then provide a proper basis for models. And it's not a case of saying is it measurements or models. They really should be considered as 2 interdependent entities when evaluating, say, current operations or investigating possible new processes. They really go together, but measurements are crucial. And when I think of measurements, I think of Lord Kelvin. And Lord Kelvin, I'd like to tell you he was a Scotsman, but he wasn't. Lord Kelvin came from Ireland, but he moved to Scotland when he was only 2 years old with his parents. And Lord Kelvin, of course, we know the name well from the temperature scale. We've got degrees Celsius, degrees Fahrenheit, and degrees Kelvin. He gave his name to that scale. Lord Kelvin became the youngest professor of physics, actually appointed at Glasgow University. He was also responsible, in charge of the team that laid the first communication cable between the United Kingdom in North America, and that had a lot to do with him receiving his knighthood. So all of that to say, Lord Kelvin, he knew the importance of measurements, and he said an interesting thing, which I used to quote to the students when I was still teaching. He said, when you can measure what you are speaking about and express it in numbers, you know something about it. When you cannot measure it, your knowledge is meager and unsatisfactory. That was strong language. But in other words, he was really saying a phrase that we've used throughout our group, as you know well, Paul. You cannot control what you cannot measure. So measurements are crucial, a crucial part of models.
Absolutely. Measurement comes first, model comes in support.
Yeah.
And that's a great phrase. And during your time at the University of Toronto, you also served as the department chair for a number of years. And it was during a time where the undergraduate curriculum was being transformed to materials engineering from the Metallurgy heavy department to reflect a broader learning areas. What challenge did you have to overcome during this time?
It was a very interesting period at that time, I have to say. That was between 92 and 97 I served as chair. And our undergraduate numbers were not large. We tended to have small numbers, maybe of the order of 15, 20, 22, 24 students. But that was small in comparison to the numbers in departments such as electrical engineering, mechanical, chemical engineering. And so the faculty really wondered, with that small number of students, should we continue to exist as a department? And a committee was formed within the faculty to look at how we might proceed. And consideration was given to the possibility of splitting the department in what seemed a very logical way, to split it between chemical metallurgists and physical metallurgists. And the chemical metallurgy people would join the chemical engineering department, and the physical metallurgy people, they would join the mechanical engineering department. And all of that seemed very reasonable, because in many other universities, that's exactly where you would find these people. The chemical guys would be with chemical engineering, the physical guys would be with mechanical. However, the department, needless to say, did not feel good about splitting in two. We did not like that idea at all. So there was a big effort made, a big campaign within the department to visit high schools. And I have to say, the faculty within the department did an extraordinary job in making a major blitz of high schools to inform them not just what metallurgy was about, but because we were moving into other materials, such as biomaterials and dental materials, the name of the department was going to be changed to recognize that, and it would be called Materials Science and Engineering. And these two things, changing our name and changing our program structure and recruiting many more students, so that now, today, the undergraduate students are generally 50 to 60 per year. That made a big difference back then. And the decision was made by our faculty, thankfully, that we could remain as a united department rather than splitting us up. And of course, since then, we've had excellent leadership with Doug Pervik serving for 10 years as chair, and you knew him well, and Jun Nogamo, another 10 years, and now Glenn Hibbard leading the department. It's well and truly established as one of the leading departments in North America.
Yeah, during that turbulent time, it's safe to say that under your leadership, the department was saved. And I am very grateful for that, for having the opportunity to go through that program myself. And it was truly an outstanding program. So thank you. Thank you for saving the program and the department.